So this is just for recording. All right, well, welcome to the second webinar in this series, where our focus is going deeper into questioning and deeper into feedback in the context of math and science. So this is the second of our formative assessment in the context of disciplinary learning webinars. And today we have David Chun and Fran Gibson, who are the math subject matter experts, and Jonathan Rodia, who is the science subject matter expert. So we're really glad to have them on board for this session and to lend their expertise. So let's begin by talking about the learning goals for this session. First of all, we want to understand what makes effective questions designed to elicit evidence in the context of formative assessment within the disciplines. And of course, those questions are going to be different depending on the nature of the disciplines and the goals and success criteria for the lesson. And then secondly, to understand what constitutes effective feedback in support of learning in the disciplines. So again, focusing on the kind of feedback that's going to support students to take steps to meet the learning goals and criteria. So those are the two goals of the webinar, and then the success criteria are first, that at the end of this you should be able to explain to a colleague the characteristics of effective questions that can elicit evidence, in this case in math and science. You should be able to explain the characteristics of effective feedback within the two disciplines of math and science, and then identify strong and weak examples of each. So that's going to be our focus, and in a sense it's an extension of what we focused on in our last face-to-face session. So if we take a look at the feedback loop, which you're now all familiar with, grounded in these three questions: where am I going? Goals and criteria: where am I now? The evidence that teachers are obtaining through questioning in relationship to student progress towards the goals, and then making some decisions about where to go next. So we're going to begin in this blue zone with the focus of intentionally asking questions to obtain evidence of learning while students are in the course of learning. And as we mentioned in the face-to-face sessions, the importance of identifying those questions ahead of time, so that you're really asking high-quality, substantive questions that are going to get at or give you insights into where student thinking is with respect to the goals and criteria. So as I mentioned, and I've said several times, both in the webinars and in face-to-face settings, the emphasis is really these days on formative assessment in the context of disciplinary learning, that it looks different in different disciplines. It's influenced and bounded by the discipline in which it occurs. And I think everybody's pretty clear, next slide please, Paul, that within the disciplines, the new standards and general understanding of what kind of learning students need to engage in content learning is the integration of those disciplinary concepts and ideas and disciplinary practices. And I think both math and our science experts will be highlighting the integration of those two components. And in fact, in math, I think, right, Jonathan, there's three, because we get to 3D science. But the idea that things don't sit on their own, but in order to learn the content, you're engaging in the disciplinary practices as well. So just want to underscore the importance of learning in the disciplines and how it varies with these ideas presented by Dylan William in a paper in 2014. And I often hear, in fact, I heard somebody quite recently from a State Department of Education comment that kids really didn't need to learn content anymore. They could figure out anything by looking it up on the handheld device or whatever other way they could connect to the internet. And so really information wasn't important anymore. It was critical thinking and these abilities to problem solve, critically think, and so on. Well, I think we all realize that it's pretty difficult to develop critical thinking in the absence of no content. You've got to think about something. That's the first point. And then the thinking that is specific to domains is, or to specific disciplines, is unlikely to generalize into a generic critical thinking skill that you can just apply across the disciplines. And Dylan William has a couple of examples here that in mathematics proof, for example, the critical thinking component will involve ensuring that each step follows from the previous one, whereas in history, a historical account, the critical thinking involved will be considering the author of the account, the potential biases and the limitations that the author may bring to the account. So this notion of critical thinking occurs within the disciplines.
I found something on the web about a stomach. Look out
and is not
involves will be considering the author of the account. Check it out.
Siri's my Siri has just heard me talk about critical thinking and is just let me know she's found something on the internet about critical thinking. So I've just switched her off. Thank you, Siri. That's pretty scary, isn't it? So anyway, going back to the idea of critical thinking and occurring within the disciplines, and of course that is what we want to support in the disciplines, and that is what we need to be formatively assessing as well. So as we discussed in the previous webinar, the teacher knowledge that's brought to bear, both for teaching and for getting evidence of learning, interpreting that evidence and acting on the evidence, really is focused in these 4 areas within the discipline: the knowledge components of the discipline, the conceptual understandings, the analytical practices, and specific skills that the discipline calls for. And so it's the integration of those 4 subdomains, if you like, that make up the idea of disciplinary learning. And of course, formative assessment is going to be focused on those particular aspects within the discipline. So with that background, what I'd like to do now is dive into questioning specifically. And as we discussed in the face-to-face sessions, questioning is a key tool in formative assessment. It's going to be one of the core ways in which you as teachers obtain evidence of learning as that learning is unfolding. So what is going on with respect to student thinking? Are there some partial understandings there? Do they fully understand it? Are there some misconceptions that you need to address? So you really want to use these questions as a means of unlocking student thinking. And I want you to recall the lesson plan that we looked at in the face-to-face session. And our math, Dave Chun, the math content expert, has added practice standards to reinforce the importance of thinking about how the relationship between the content standards and the practice standards in mathematics. So I'm appreciative of that. So from the standards, we identified the learning goal, the success criteria, the ways in which students are going to be assisted to meet that goal through the various tasks, activities, strategies you plan, and then what are the formative opportunities within those learning experiences as kids are engaged in their learning tasks or their activities. What ways are you going to be able to access their thinking? And then the kinds of questions that you can ask during their activities so that you can augment the evidence basis for your decisions by really probing that thinking. And this is our focus today, and the kinds of questions that really target the goals and criteria to give you the information you need so you can act on it to move that learning closer to the goal and criteria. So this brings us back to the idea of planning good questions to elicit evidence, to really think it through beforehand. That's not to say that questions won't come up during the lesson, obviously they will, but experience suggests that the more teachers plan these good questions, the more effective they are as formative assessment tools in the lesson. And the idea is that a few carefully planned questions are preferable to a large number of questions. So really thinking about the learning tasks that the students are going to be engaged in and what kinds of questions you can use in combination with those tasks that are really going to give you insights into their thinking, or the kinds of questions that you might want to ask at the beginning of the lesson to find out what kids are actually bringing to the learning that day. And the other point to remember is that once you've figured out what are really good questions for certain lessons, you can also preserve those questions. It's not that they go away. If they were valuable in one instance, they're probably going to be valuable again. So you can begin to build up a repertoire of questions focused on specific goals and criteria that can be used subsequently in other lessons. So when you're asking a well thought out question, you can basically access 4 different kinds of thinking. First of all, what are students bringing to the lesson? And I'll remind you of the lesson I showed you from Sharon, that 6th grade math teacher, where she asked questions to assess what students were bringing to the lesson. Then the second one is providing insights into the current status of student learning during the lesson. So as they're developing these ideas and these practices in math and science, where are they as the lesson progresses, as they're engaged in the learning? What are they thinking? How are they thinking? And what do you need to do to keep that learning going forward toward the goal? The other means of questions, and this is when it's really helpful to know what potential misconceptions are with respect to particular goals and criteria, so that you can identify any particular gaps in their knowledge that are preventing them from understanding what you want them to understand, those gaps that need to be filled, or any misconceptions that students have. And as I'm sure our subject matter folks will let us know, there's a lot of documentation about the kinds of naive conceptions or misconceptions that students have in relation to certain topics in mathematics and science. So it's important to use questioning to uncover those so that you can clear them up before they become too firmly consolidated. And then the final one, assessing what students take from the lesson. And I hope you recall the lesson I showed you on conjecturing about functions. The teacher had 2 questions, that middle school teacher. At the end, she asked the students to think about what math practices they had used in the lesson and how they'd help them understand the math that they were learning. And the second one, she left them a written question to respond to, so she had a sense of where their thinking had ended up at the end of the lesson, so she could build on it the next day. So questions can be used in each and all of these areas during a lesson. And the important point, once again, to underscore is that you are really identifying those questions that will give you the information you need. So not a gazillion questions, but questions that target the learning goals and success criteria. You may ask a whole load of other questions that might be interesting questions to know the answers to, but they're not necessarily going to give you the information about the targets, and that's going to be a really important consideration there. Okay, so just a reminder then of the lesson I showed you and the questions that Sharon Panisi, a 6th grade teacher, had identified. And as I pointed out previously in the face-to-face session, this is how she at least started thinking about questions in a lesson. It's not necessary that you think in this way, and I don't even know if Sharon still thinks this way, but this is her early stages of implementation. So she thought of questions at the start of the lesson. You know, what comes to mind when you think of coordinate graphing? Are we in agreement with the definitions? Are any big ideas missing? So really getting a sense of what the students are bringing to the lesson. In the middle of the lesson, as students were really learning about plotting points on a coordinate grid, she was asking another range of questions really targeted at the learning goals. Where would you start? I mean, what are you thinking is a generic question that you can ask in any discipline, but the other questions here are really targeted on the goals and the criteria. And then at the end of the lesson, where they'd actually created coordinates, she was asking questions about what they're noticing, how they're alike or different, again, really targeting those goals. So she could make sure that kids were understanding the goals of the lesson, and if they weren't, she had opportunities to intervene and make some adjustments so that they were getting the point of the entire 2-class period lesson. So in thinking about types of questions, I've got a couple of different slides to help frame some ideas around the types of questions that you might think about asking, remembering that these are all targeted on those the learning goal and success criteria. So closed answer questions, which I'm sure you're familiar with, those that check on students' memory or recall of facts. So typically there's only one right answer. And, you know, it's important sometimes to know that kids can remember things and they can recall facts. But if you have a steady diet of that in your lesson, then it doesn't bode well for kids' conceptual understanding or for their critical thinking. So it's as well to be aware of the kinds of questions you're planning and the kinds of questions you're asking. And just to remind you of what I said in the face-to-face session, that it's still a predominant method of questioning in American classrooms is the initiation. I ask a question, student gives a response, and then I evaluate the response as either right or wrong. So an open question is one that has more than one answer. They typically promote higher order thinking skills, and they are going to be your friend in terms of really getting insights into student thinking. Where's that thinking right now? How are they thinking about this math idea or this science idea? That's what you really want to know. And then a third, this idea of a low risk question, that it's not right or wrong. And I think, although I didn't have it on the screen, at some point Sharon Panisi asks the students at the beginning, what comes to mind when you think of coordinate graphing? So that's a nice way, I think, of getting some ideas about how they're thinking about a topic before you really begin a lesson. And there may be some immediate adjustments that you have to make or immediate responses that you have to make as a result of what the students say. So that's one way of thinking of different types of questions. And then similarly, but a little bit more detailed, this idea of broad questions and focused questions. So broad questions are open-ended questions. For example, how are these two ideas connected? So you're really getting some insights into how kids are thinking, how they're thinking critically here. Analysis kind of questions. How would you interpret X or Y? So you're, again, probing that thinking. You want to get into that analytic thinking by questions like that. And then prediction, again, probing analytic thinking, what will happen if? I'm imagining, John, in science, there's going to be a lot of those kinds of questions, but I'll wait for you to let me know if I'm correct or not on that. And then focus questions, you know, recalling facts, which are going to be important, but as I mentioned before, you don't want a diet of these questions. What is the function of this structure? That may be really important for kids to know so that they can build conceptual understanding on that knowledge. Similarly, defining terms. That's important to know precise terms, precise language. What is X? Or categorizing questions. What are the characteristics of X, Y, and Z? What do they share? So that's another schema for thinking about the kinds of questions you want to get, you want to ask, focused on the types of thinking and understanding and knowledge that you want to assess. And I think this just underscores the care with which teachers need to plan these questions to make sure they're really targeting the questions at the learning goals and success criteria, and gaining insights into where students are. So we go to the next one. This is an amalgam of various people's ideas related to Bloom's taxonomy. We start with the level, remembering, and then the actions that are prompted through questioning would be to identify, to show, to define, or to name. Can you show this? Can you define this term? Can you name this whatever? And then we have understanding, and I'm very fond of understanding questions where you're asking kids to explain something, describe something, compare something, or interpret something. So those are the kinds of areas of focus, or the action in thinking that they prompt to get at students' understanding. Then we want them to be able to apply their understanding. So can they, can you go back please, Paul? So can they relate, manipulate, use, solve, and apply? So that understanding then becomes something that they're using through application and then analyzing. So you might ask questions related to analysis, organization, deductions, comparisons, and contrasts. Evaluating, you're asking kids to evaluate, justify, assess. And then the very top of the tree, design, hypothesize, devise, create, construct. So that's quite a useful, you will have these slides, so that I think is quite a useful aide-memoire to help you think about what is the goal. Is the goal to do with understanding something? Is it to do with evaluating something or analyzing? Then these are the kinds of prompts, the kinds of actions that you can prompt kids to engage in through the sorts of questions you ask. So let's go to this pyramid, which actually I found from an organisation in Scotland, of all places. And I think this is quite useful in terms of looking at this pyramid, Bloom's levels, and the sorts of questions. You know, can you explain the writer's ideas? What are the parts or the features of? How is an example related to? How could you design or invent a new way to do this? What would you infer from this? What ideas can you add? So these are the sorts of questions that it's useful for you to bear in mind depending on what is the goal of the lesson. And so next slide, please. And to finish off this section, before I invite the subject matter experts to contribute the detail about this idea of questioning in the disciplines, I want to share some ideas about maximizing student responses. First of all, you can maximize their responses getting insights into thinking through open questions that really invite kids to tackle ideas, to think about ideas, and express their understanding. We've mentioned this in the face-to-face session, the importance of increasing wait time. Teachers wait far too little time to give students time to think about a question. I mean, if a question is worth asking, it's worth giving kids time to think about it before you have a response. The idea of no hands up, I think I've seen this be very, very useful, and more people are advocating this, that, you know, when you allow hands up, you have the kids who always answer the questions and those that don't. So the idea of making students accountable, one. And two, your job as a teacher is to understand what each child is. So you don't want to call on different students at different times, and give everybody a chance to show where they are in their learning. So I think a no hands up policy is a useful strategy. This is one of my favorites, asking students to elaborate on their answers and asking why. Why do you think that? Why will that work? Why does this analysis work in the way it does? So that extra layer of probing that can come from a why question after you've already asked an initial question, I think is good to note. And then continuing to probe in the event that a student response is inaccurate or unclear. You're not looking for the right or wrong here. The right or wrong may be important later in the day, but right now you want to understand where kids are in their thinking. That's one thing the new college and career age standards have really emphasized, new ideas about, or contemporary ideas about learning, that we want to build on students' thinking. So instead of saying you're wrong, make comments like, that's interesting, what makes you say that? And again, it gives you another opportunity to dig a little bit deeper and find out why students have given you the response they have. Not interrupting the student's answer, and you may well say, well, I never do that, but I bet you do, because most teachers I've seen, including myself, do that, either to help students who are taking time or struggling a little bit to form their ideas. They need to have practice in doing that. So not interrupting their answers, not excuse me, finishing the answer for them. They need time to practice. And then also not answering your own question. Excuse me. If after about 10 seconds or more of wait time, and that's how long you should be waiting, if they haven't answered the question, then don't you answer it, but rephrase it to make it probably more accessible, or to give them another shot at answering it. So those are some ways in which you can maximize your questioning in the classroom to get the best response from students. So what I'm going to do now is hand over to our subject matter experts. We've got Dave, Fran, and John. So let me hand over to them, and they're going to take it on questioning in the disciplines. Thank you.
Hello, everyone. We have some science-specific questions here, and just some basic ones, especially when you are first having students engage in a phenomenon. What do you notice? What do you wonder? As a formative assessment to see what is resonating with them according to the phenomenon. And what does it prompt them to be curious about? Some kind of some kind of core aspects of doing science and noticing things around. And what do you think is the reason that sort of thing occurred? And what is your evidence? And those questions are based more on the fact that, you know, and when we do science, we want to base our conclusions about things on appropriate evidence. We can start that off right away at the beginning of a lesson when we are looking at also, Margaret mentioned that, you know, with the math and the science subject matters, our standards now have these things called practices, and science has even another list of things called cross-cutting concepts. And so if we follow that cross-cutting symbolsweebly.com link, so if we could click on that. Are we able to open that? There we go. This is a great site that has the 7 cross-cutting concepts. And if we were to click on one of those tiles, you know, such as patterns, and open that up, we kind of get an example of what patterns are. But if we keep scrolling down, we will eventually arrive at possible questions for investigating something based on patterns. And so, is there a pattern? What is the evidence for this pattern? Do similarities and differences reveal a pattern? So there's a number of questions here at this resource that correlate to the 7 cross-cutting concepts. And I think this is just a great resource as you're trying to develop a lesson that is 3-dimensional, to start with either the practices or, in this case, the cross-cutting concepts. And can you ask students questions or get them to ponder things in line with that concept? So this resource can help. And then each of them, toward the bottom, I don't know if you can see where the breaks there, questions that connect to science and engineering practices. So that would be looking at the lens of the cross-cutting concept patterns. Then we have the practices, asking questions, defining problems and models. And if you were to blend those 2 dimensions, practices and cross-cutting concepts, what sort of questions could you ask? And so it's an awfully lot of questionings that you could do. And that's just under the patterns.
This is really helpful. I would also think it's helpful for lesson planning as well, when you're, or maybe there's other tools on this site for that. But I can imagine if you're wanting to review this from the point of view of lesson planning, it could be very helpful, and then building in these questions around the specific things that kids are focusing on. This is great.
Yeah, I've enjoyed this site immensely, and I've returned to it frequently, and just for that same reason, for lesson planning.
Mm-hmm.
And if we go back one screen, each of those tiles had a certain icon, and that site has little posters you can print off for your room of those icons. And so you could even point to that poster and say, we're going to be in energy and matter today. And, you use questions and focus on that cross-cutting concept. You could still incorporate many different practices while staying in that energy and matter cross-cutting concept. Mm-hmm. And so at the top of the site, or even right there, it has a link to the PDF of the cross-cut symbols for classroom use. You can get these icons up on your walls in your classroom.
And I would think that could be very helpful when you're conveying learning goals and criteria to students, as a way for them to keep in mind what the focus is, what the bigger picture is.
Yeah, so not only is the question something that, as a teacher, you incorporated in your lesson, but the students can also be very aware, well, we are in this cross-cutting concept as we look at this phenomena. And it's interesting, you could even possibly in another part of the lesson or another day focus on the same phenomena, but under a different cross-cutting concept.
Mm-hmm.
And how does the investigation of the phenomena differ when we move from one cross-cutting concept to another? So this is a good tool. I recommend using it.
Yeah. And just to go back to my 4 categories of questions for a second, Jonathan, these, you could categorize these as questions to what kids are bringing with them to the topic, then assessing what they're bringing with them to the lesson.
Yes, yeah, certainly.
Mm-hmm. And a teacher, if you could just go back to that slide for a second, a teacher could then have to, in planning, think about, based on what students respond to this. There's no point asking questions if you're not going to do anything with it. What kind of teacher responses you would make, because this obviously is evidence about their initial thoughts. So what are you going to do as a teacher to take on these ideas and develop them?
Yeah, very true. Like, do they notice the things that you thought they would notice?
Yeah, exactly.
Wondering about the things that you anticipated that they would wonder about.
Mm-hmm.
And if not, how are you going to then ask follow-up questions, or your teacher, that might lead them to pondering some of the target concepts you were hoping for? Or it might lead you to, oh, is there another phenomena that I should showcase? And so, yeah, it's very much an assessment tool.
Yeah, nice.
Shall we move on to, there we go.
Okay, so moving on to math, I'll start here. This list of questions is a good list to get students thinking in terms of mathematics. Does your answer make sense? Is a question that I think can be used in just about any situation and any grade level. Okay? Another powerful question is why. Getting students to explain why. And Margaret mentioned earlier the different aspects of math, whether we're talking about concept or skills and fluency or application. Why really moves toward a conceptual understanding. Asking students to consider, how do you know this, and to explain their thinking is another valuable piece in terms of getting students to look beyond just answer getting, because just the arriving at an answer doesn't necessarily indicate that students really understand the math that goes behind it. Asking students to prove something moves in that direction also. And another valuable question in math is, can you solve it another way? In terms of question types, if your question only has one answer or only one likely possible solution pathway, it might be a good question, but it's certainly not a high-level task. And not that all of the tasks in math have to be high level, but certainly some of the tasks that we're asking kids to do should be able to be done in another way. And another area that moves toward conceptual understanding is if they can draw a picture or a diagram. It is an important piece. And then I'll let Fran continue. I've kind of gone through all of the questions except for the smart mistake, so I'll let Fran pick up here.
Well, one of the things that I think question asking for the teacher will give them feedback, but I think what it does for the student is it creates a new habit. We run into a lot of math students that don't think that mathematics should make sense because they just sort of pull numbers out of a problem, crunch them somehow, and they say things like, it's what I got, and they have no basis for what they did. So I think in asking a lot of questions in the math classroom, you're creating a new habit. So students, one, believe mathematics should make sense, and then they start asking themselves these questions when they're thinking and trying to solve a problem, or when they're listening to someone who has solved the problem. So I think that's really important. I think the last bullet is actually a very high level question, because it's asking students with a typical mistake. Like, for instance, today I was doing in second grade a number talk, and the number talk was 81 subtract 29. And the two answers that came up every time were 52 and 68. And so 52 is the correct answer, in case you don't want to calculate it. But 68 is a really super smart mistake, because when you're 7 years old, and we write it horizontally, so we do not set it up in the algorithm. We write it horizontally, and they have to calculate in their head. So they really have to stay in place value. And so what kiddos do is they say, well, 80 minus 20 is 60, and then they see the 1 from the 81 and the 9 from the 29, and they say, well, shoot, I can't do 1 subtract 9, or so they think, so they've been told. So I'll just subtract 1 from 9 and I get 68. And they're fine with that. I mean, they're fine. And so the idea of kind of debating that out a little bit and then saying, okay, we do agree that 52 is the correct answer, but why is 68 a super smart mistake? What's going on there? And that's a real high level of thinking and analyzing. So I think it's really important to ask that question a lot too.
That's a great question, Fran, and a great example of how you can get really important insights into how the students are thinking mathematically. So a really nice example, as they all are.
I didn't hear it. I didn't hear what you said, Margaret. Sorry.
Oh, I was just saying it was a great example.
Oh, okay. Thank you.
In summary, so can you just go back a second, Paul, to those questions? So basically, you would think about. I mean, this is good to have a repertoire, and presumably at different points in the lesson, these are the range of questions you can ask depending on what you want to find out. So it's great to have this set of mathematically oriented questions, and for a teacher, the trick is going to be, when do you ask these questions in order to find out for yourself what it is that you want to know about how students are thinking. So that's great. Yeah, I've never heard of that one. Why is this a smart mistake? But I shall be sharing that broadly, Fran, I promise.
Well, I did have a little girl today who wasn't going to relent. She liked her smart mistake, and she wasn't going to change her mind. So sometimes you find, her name was Eleanor, you find the Eleanors out there who say, nope, I'm sticking with 68. And you're like, well, okay, we'll try this problem again. A different one tomorrow that's similar.
Yeah, we'll change her mind gradually.
We're working on her.
Yeah, we appreciate her confidence. We need strong women in this world. All right, well, thank you for that. So let's now move to just some final reflection for teachers, for you to be thinking about questioning. So it's when you're in the weeds of teaching, it's really hard to. I mean, it's a long time since I was a teacher, but I still remember that if somebody asked me to think about my practice, I was too busy doing it to be really metacognitive. So I think at some point to take a sort of post-action reflection and think about the ways you use questions to elicit evidence, the proportion of your questions, what are really designed to give you those insights that you want, the kinds of questions that we just reviewed, versus the more managerial questions, just getting through the lesson, getting things done. And then a final thought is how could you improve your questioning to elicit evidence? Perhaps going back to the taxonomy of actions that are shared with you, the kinds of questions that have been shared from our subject matter experts as well, to give you a sense of maybe I can improve, maybe I'm not getting the information that's really valuable to me. And then thinking about, what did I get from asking these questions? Was it worthwhile? Could I act on it? Did it give me the kind of information that I need in order to keep my students' learning moving forward? So some reflection for you. So let's now move into the idea of feedback. This is our second strand of the webinar. Thinking about the feedback we give to students in the context of the discipline, the subject matter. So just a reminder back to our feedback loop, that the questioning was about where am I now, but the feedback becomes where to next. What am I doing to help the student take next steps in their own learning? And the important word here is descriptive feedback to students. That's the goal in formative assessment, that there is descriptive feedback that gives the students an indication of where they are and then provides them with some guidance about where they can go next in order to advance. And I shared this with you at the face-to-face session, but I think it bears repeating, that if we look at John Hattie's analyses of influences on learning and the effect size of these influences, we can see that feedback is one of the primary influences on learning. It's a powerful influence when it's done well. And as I mentioned in the face-to-face session, feedback isn't always done well, and we'll come to that in a moment. And I want to share with you this quote from the Ministry of Education New Zealand. I think I know I've told you how much I admire what the folks in New Zealand do in terms of formative assessment, including feedback. And of course, John Hattie was in New Zealand for a long time and is now in Australia, but a big influence on New Zealand educators. And this is from their ministry, and the ministry says that teachers who combine strong subject matter knowledge with effective feedback can offer students rich, focused information about their learning and how to improve it. So once again, we're seeing that subject matter knowledge, which means not just how to do the subject. You know, are you, as a teacher, good at science, or are you good at math? Hopefully you are. But do you understand how student learning within the discipline develops? What meeting various goals and criteria actually entails? Because when you have that depth of knowledge, you're able to use it to give the kind of feedback that's going to help kids move their own learning forward. So just to remind you that, first of all, if feedback is effective, it first of all needs, students need to understand the goal. What are they aiming for? And it's not just understanding it in terms of, oh yeah, I can read my learning goal, but they are very clear what meeting that goal entails, potentially haven't seen exemplars of quality, and they understand the success criteria. So it's a lot more than just telling kids this is the learning objective for today. They really need to understand what meeting that goal and criteria entails. And then they need evidence about their present position in relation to the goal. So that translates into, what are they doing well? How are they meeting the goal? Why are they doing that? And then finally, some guidance on how they can close the gap between the two. Remember, the whole point of formative assessment is to close the gap between where the student is at the start of the lesson and where you want the student to be at the end. And so we've seen that formative assessment in terms of teachers using evidence, making those instructional adjustments, but now with feedback, next slide please, we're actually thinking about the kind of feedback that students can use for themselves to help them meet the learning goal. And that the kind of feedback that teachers give will depend very much on the age and experience of the students. I wouldn't expect students in kindergarten to have the same kind of feedback as they would in 10th grade. For obvious reasons, I'm not even going to waste your time going into that. The important point here, though, is that students use the feedback. There is absolutely no point giving feedback to students if you don't give them the opportunity to use it. You may as well just continue and do what you do. As we'll talk next time when I see you in person, about how students can use feedback and how students are developing their agency, those self-regulatory learning processes, which increasingly we see as important to life beyond K-12 schooling. And so just to underscore here that the feedback needs to be actionable by students, and students need to have opportunities to use the feedback. So in terms of some of the characteristics of feedback then, the feedback needs to focus on what's being learned related to the goals and criteria. Just as we said, the questions need to be focused on the goals and criteria and getting to them. There are plenty of questions you can ask students that might be interesting mathematically or scientifically, but they're not focused on the goal. And so the same with feedback is that the whole point, as I just said, was to help students take action to meet the goal. So it's got to be focused on the goal. It occurs as students are doing the learning. So feedback after they've had the learning opportunities, I mean, it can be useful, but it's maximally beneficial if students are engaged in the process of learning these math ideas, math practices, science ideas, science practices, and so on. Feedback needs to be descriptive and to give information on how and why the student has met the criteria, and how and why the student has not met the criteria. In some of the videos we've seen, and one in particular, the teacher used the idea of a star and a step with her second grade students. So the information about the star is how and why they've met the criteria, but then the second part, the step, should be the guidance, where they've not met the criteria, combined with guidance. If you can click again, Paul, guidance on how to improve. And this is particularly important in, well, in all subjects, but particularly important in math and science, that you don't give the students the solutions. The idea of feedback is not to give them the solutions, but to engage their thinking so they can take their own learning forward. Just enough guidance, so you're not leaving them in the lurch, but you're letting them know, yes, this is where you're on track, and pointing to where they need to go next, so they can take action for themselves. So the couple of examples then of feedback is in math. Remember we talked about slope as in the change of y divided by the change of x from a to b. See if you can find the change in y from point A to B. I'll be back to check in a few minutes. So you're giving the students some feedback, and clearly the teacher's intending to come and see how the students used it. The next one related to science, you planned your test in general terms. Now think about how you would conduct your test in a systematic way so you can draw conclusions. So again, you've told the student what they're doing well, how they're moving towards the goal, but now to really pinpoint how they can improve their science inquiry. Now the evaluative feedback, that's descriptive feedback. This kind of evaluative feedback is not what we want to be seeing in classrooms for pretty obvious reasons. But things like that's good problem solving or you've done well, while it might make a student feel good, it has no relevance to descriptive feedback because it doesn't tell them why they've done well, so that they can use those strategies another time in a similar context. And to say that's not good enough or you need to do that over, that is not helpful feedback for obvious reasons. It doesn't tell them why, and it doesn't tell them how to think about doing it over. Not to mention the likely effect it's going to have on students' feelings of self-worth and their ability to actually engage in subject matter learning. So we don't want to see evaluative feedback, but the idea of descriptive feedback is it's constructive, it's focusing on what the students are doing well, and gives them information about how to move forward. So I've taken this again from the Ministry of Education because as a country I think they've done more on feedback than anywhere else I know. And these are just really helpful ideas to be thinking about when feedback is most effective. When it's initiated by the student, when students are using their self-assessment or information from peer feedback to request feedback from the teacher. And in some of the face-to-face sessions last time, I showed you that happening in practice where a student has assessed her writing and asked the teacher for feedback. The second one is gauging when feedback is necessary, when it's actually going to really support the learning. And this comes back to knowing your students. One of the things I keep stressing is that formative assessment doesn't happen in a vacuum. It happens in relationship to individual students, and each one is different. So when you know your students, you have a much better sense of when that feedback is needed. And when you have the disciplinary knowledge related to how students learn the content, what the typical kind of pathway is, you have a better sense of when to provide that feedback again. So thinking about your feedback that really meets the needs of the students at the kind of level of support they need. Some students may need a lot more than others. It depends, once again, on the student. It depends on the level of their thinking, where they are, and how much support they're going to need to take the feedback for themselves. Allowing time for students to use the feedback, again, really stressing that it's pointless. Don't bother doing it if you're not going to have them use it. And it does also advantage the development of those self-regulated learning processes. And then feedback takes place as a conversation. Kids have an opportunity to ask questions, to really engage in dialogue around the feedback, rather than this just one-directional, I'm giving you this feedback. So it becomes a conversation. And particularly when it's a conversation, it really removes the burden from, especially middle school and high school teachers, of giving written feedback. That's not to say written feedback isn't valuable, but I'm realistic in terms of what is possible for teachers to do when they have many students. And so the more you can engage in conversation with the feedback, I think the better it's going to be all around. And then the final thing is to make sure that the feedback's adequate. Before you leave the conversation, to be asking questions like, did you understand the feedback? Is it enough? Is it helpful? Can you go to the next slide, please, Paul? Do you know what to do next? What will you do if you get stuck again? So you really want them to understand the nature of the feedback, and for you to be confident that it's going to be worthwhile and useful. Because clearly, if it's not perceived as worthwhile and useful by the student, they're not going to bother. They'll just blow it off and think, oh, this is just another thing, but I don't need to pay any attention to this. So one last bullet, Paul, on this one. This is what will you do if you get stuck again? Do you need more feedback? Can you go back and refer to this feedback? So really engaging in the student's own agency in the learning process there. So let's now take a look at feedback within the disciplines and go back to our subject matter specialists. So we're going to have science first. Yep, we are.
Yeah, so I added a few feedback questions that I hope would facilitate students connecting ideas to different concepts and so forth. So like the first one, was the strongest and weakest part of your model? And a follow-up might be, how aware could you get more evidence to strengthen, a hypothesis, or could be to strengthen that part of your model. What else could you use? What would happen if we applied this concept, one that you've been studying, to this brand new setting? So it could be studying interactions of certain, species within a biome to a completely different sort of biome where you're analyzing how they interact. It could also incorporate, one setting to another setting that increases in, ratio or the population. And so that could lend itself to scaling up sort of question. The next bullet, how is your structure accomplishing the desired function? There's a cross-cutting concept that is structure and function. And so questions, directly linking to those cross-cutting concepts could help too. And what if we changed our structure? Would it meet that function a little bit more precisely or efficiently? So the next one, can you trace the flow of matter through the system? Can you trace the energy through the system? So systems and system models is one of the practices we want kids to do. And matter and energy was a cross-cutting concept. So again, we're linking two of these ideas to create a strategic question, to give feedback. is this a closed or open system, and how do you know? And then always praised for effort and perseverance. Whenever you are using these questions to help students link ideas to concepts as they try, putting more emphasis on that their effort and perseverance is of the greatest worth, as opposed to right or wrong having the greatest worth. Because the journey of making connections to different concepts is just a process, and right or wrong is part of that process. But the effort and perseverance through that process is what accomplishes the learning.
Thank you. So I'm thinking here that these kinds of questions will be prompts once the students had engaged in part of the learning. So for example, the first one, they would have created a model, and then the feedback could be, you know, I see that you've really worked hard and persevered in creating this model. Now can you think about what's the strongest and weakest part of your model? So it might actually go like that. Is that how you're thinking about these, Jonathan? So this would come after a period of learning.
One, as well as, you know, I think you mentioned that, you know, sometimes feedback comes from the teacher to the student, and sometimes we're facilitating the student to reanalyze their own work and identify. That one could also be student to student, or a group of students analyzing a sample model. You know, so lots of different ways that you could get that question to make a connection, the desired connection that you're seeing that the student needs to still make.
So this is all about making connections. And what I do see here is that you're pushing the thinking with each question. They really engage kids thinking this type of feedback, and you're pushing them to think further and deeper. At least that's what it seems to me.
Yeah.
If that was the intention, but you would agree. But I think these are very clear in terms of how they engage students' thinking.
Yeah, they are question prompts to get students to think further, and I did focus in on that form of feedback because I feel like a lot of times we as educators will, you know, jump in and maybe reveal the answer too quick.
Yeah.
You know? And so although I mean, my own daughter, for example, loves knowing her new Lexile level, right? She just loves numerical feedback, and she just thinks it's awesome if she moves up. You know? So I think that's valuable feedback too, you know, or a score that students get on a rubric and related back to the categories of a rubric, I think could be really good feedback, especially if it's a first draft of a project or something, you know, they're still working on it and they just want to know about where they're at. You know, I think that's great feedback as well. I think the trickiest type of feedback for teachers to do is to look at something that's in progress and come up with a teacher move type question that has the student look a little deeper at what they're doing and come up with the idea of where to go through self-reflection.
And that's the goal. That's the goal of the feedback. So those are great. So should we turn to math?
Certainly. So moving ahead to math, and I think math is very similar in context to what has already been discussed. I believe that I would underscore and highlight what you mentioned about feedback being a conversation with a student. And so these questions are really framed in that picture of a conversation for students to self-reflect on where they're at in the learning process, and without giving them the next step, to be able to prompt them with a question to move to the next step. And one thing that I will also share as a frame is in reaction to the evaluative feedback that was already mentioned, and another frame for the negative evaluation might be a deficit-based feedback. I think a positive way to frame it would be an asset-based feedback, where students are prompted to look at what was done correctly and analyze what's right versus what's wrong. So we look at what's been done, what is correct, okay? And it's not the idea of you got the wrong answer, but what are the steps of this that you know are correct? What about your process is right? And have them explain that, and in the dialogue be able to understand if they're utilizing the right process and the right conceptual understanding. And also, how can you use the students' strengths to then support their misunderstandings, or what they don't understand is an important piece to reflect on. And John already mentioned that the value of praising for perseverance versus just praising that they're smart or something of that nature. Fran, anything to add in on this one?
No, I apologize. My dog was barking. I think one of the things I think everything both John and Dave talked about is very important. And I think all I want to add to is sort of the hierarchy of task that gets you the best evidence, that maybe the typical worksheet in a math lesson is really not giving you the evidence you think you're getting, versus a struggle problem versus something really big. And in math, we might do our phenomena as a 3-act math task where kids are really thinking and pondering. And so to do a variety of tasks so you can collect a variety of evidence and not just stay narrow in the lower levels.
Yeah, that's a really good point, Fran. It's very hard to do formative assessment. You have these narrowly defined tasks, the worksheets of 50,000 problems and so on. The responses of the teacher become either to say it's correct or incorrect. There's really very little access to the student's thinking, which is really what we're going for here. And in fact, there's been quite a bit written about that. So I think that's a really important point about, the design of the task, and does it engage thinking, and does it give you those insights, and is it a higher level task that's going to lead to some worthwhile learning? Granted, I'm sure we all want kids to be able to do 50,000 problems in 2 minutes and get them all right, ultimately. But nonetheless, the emphasis on conceptual understanding, I think, is really significant in how people are thinking these days about mathematics teaching. Although I have to say, when I was learning to be a teacher 1,000,000 years ago, it was still drummed into us about conceptual understanding. So, but maybe that was because it was in England, and I don't know, but
maybe
it was beaten into us in. That it was about conceptual understanding, and that you had to have that in order to hang any kind of procedures onto it. So that's a great idea. And I just want to underscore the idea of praise for effort and perseverance, but in the context of specific feedback about how they can move forward. These are habits of learning that we want kids to consistently maintain, the effort and perseverance. So it's not like you're saying, well, you're a great kid, or I really like you. But I noticed that through your effort and through your perseverance, this is what you've accomplished. Now let's think about, and that's great. So how can, here's some suggestions about how to move forward. So those are great ideas. And I hope people listening to this webinar can see how specific these are within the disciplines of math and science. That if you had been on the webinar, previous webinar for English language arts and history social sciences, you would have seen a very different set of feedback. So just to end up this section on feedback, then something for, oh, we've still got math, ineffective feedback. I'm sorry.
We did add in some examples of ineffective feedback.
Yeah, nice.
And I think we've talked about this briefly, but you know, ineffective feedback would be, you know, that's wrong, or you know, this is wrong. That doesn't really prompt them further in their thinking. Or ineffective feedback would be telling them the next step, because that doesn't help in the learning process. If students get accustomed to us giving them the next step, then that's what they're always going to ask for. And I would just circle back to how important the tasks are that we're asking students to do, because if the tasks really do just come down to one answer and one way to get there, it's difficult to come up with effective feedback in that context. So if it's just simply a one right or wrong answer, I think that's where oftentimes the feedback does rest in this, you know, deficit of what you did wrong. But the task selection is so important to then giving foundation for effective feedback.
And once again, that comes back to subject matter knowledge. You know, all roads are straight and lead to subject matter knowledge is the underpinning both for instruction and formative assessment. And I think this categorization of asset-based and deficit-based is very helpful. You know, I think that would be a good way for teachers to reflect on their own feedback. Is it asset-based or is it deficit-based? So I think those are useful constructs. Thank you for sharing them. So the next slide then, just to wrap this all up, is really ways for you to think about the kind of feedback that you're giving. What is it, deficit-based? Is it asset-based? Does it provide solutions, or does it engage thinking and promote students' own learning agency? Which of the ways in which you give feedback do you think actually helps improve students, improve their own learning? And you know, are you giving evaluative or descriptive? Which types of feedback are you giving? The ways in which you give feedback, are they more evaluative or are they more descriptive? And then finally, what's the role of the students in the feedback process? Do you engage students in conversation? Do you give them time to think about the adequacy of the feedback? Do you give them time to use the feedback? Do you check back with them? Do you allow them to check back with you that they've used the feedback effectively? So thinking about the role of students, and we'll talk more about that as well in our next face-to-face session, but how can this be enhanced? And going back to my much earlier point that it's hard to be reflective about your own practice when you're in the weeds of actually managing and teaching a lesson. Sometimes it's valuable to have a peer to come in and observe. So you could just say, can you listen to how I give feedback to my students and give me some ideas about whether it's evaluative or it's descriptive or how I might improve it. And in our face-to-face session, I'm going to be talking a lot more about protocols to support reflection and peer observation on practice. So that's just something for you to think about. So before we wind up, I'm just going to see if Fran or Dave or Jonathan have any other comments. They don't have questions, but do they have any other comments they wish to make for the good of the order?
I do know that when we really concentrate on good questioning to get great feedback, it's much easier to plan what we're going to teach and plan the decisions we're going to make. So it may be a new habit to really pay attention to what kids know, what they're questioning, maybe what they misunderstand, to help us make our next decision. But it makes things a lot easier.
Yeah, it's not working harder, it's working smarter.
Yes, yes.
That's what so many teachers have told me, that, you know, it's not harder work, it's smarter work.
Mm-hmm.
It takes a while and it's challenging to get really good at doing it, but it's worth the investment in the long run. So sort of go slow to go fast. So thank you for that. So I'm just going to let you read the goals that we had for this webinar. But before I do that, I am going to sum up. We talked about pre-planning questions for eliciting evidence of learning. The more you pre-plan, the more the kinds of questions you ask will give you the insights you need in relation to the goals and criteria. That the whole point in formative assessment is providing that descriptive feedback based on what you found out about students to help them close the gap between where they are and the desired goal. And then the really important part of all this webinar and previous webinars is the value of disciplinary knowledge. That the more you know about your discipline, not just in terms of the content of how to do science or to do math, but how thinking develops and the kinds of important connections that kids need to be making across the disciplines and with the practices, that's going to really help in your questioning and the way you can provide feedback. So I'm going to just let you read the success criteria, and those of you who are looking at this now can determine whether you feel you've met those criteria or whether you need to do some more thinking or go back to the book you were given, the book I wrote on formative assessment, making it happen in the classroom, because there's more information on all of this. But I really, really want to thank our subject matter experts, Dave and Fran and Jonathan, for joining us. Deepen the conversation so much more with their expertise, and so I'm really appreciative of that. So thank you. I know you're super busy, but this has just been great to have you participate in these. And again to Paul for driving the whole thing and making sure that we started and we finished and we had stuff in between. So thank you very much, Paul, and thank you everybody.